No, I'm watching the video.
Yeah. Hello. Good evening.
Hello, now we can
Yes. You were not here because I wasn't talking.
hear you.
So good evening, and you are all welcome to this evening's tutorial. I waited for some 20 minutes so that we can get a stable number of us online, then we can start. I hope we are all behind our laptops, having our textbooks beside us, as well as our Jupyter notebooks running, because we are going to basically go through what we've been looking at for the past weeks, most especially the topic we are treating currently. But before we begin, um, I would want to ask if anyone has a question or a clarification from our exploration and the practice we've been doing by ourselves. If you have a question, any issue you need clarification on, You can unmute yourself, then you ask. And let's use about 5 minutes or maybe some 3 to 5 minutes to do that. Then we can start what we'll be doing for today. So if you have any issue, any question, clarification, you just unmute yourself, you identify yourself as well, then you speak. Uh, uh, um, can we hear me clearly? Yeah, so
Yes.
I was saying if you have a question or a clarification from your personal studies or maybe your group discussions, you were reading and you came across something that you need clarification on, you can just unmute yourself, you identify yourself, then you ask your question. You are using just the first 3 minutes to do that. Then we can do what we'll be doing for today. So if you have a question, you need clarification on something you've come across, you kindly unmute yourself, then you ask your question. Okay, so I will take it as though none of us have any question. So we'll be doing a step-by-step tutorial. That is, we are going to go through what we've been doing for the past weeks. More specifically, issues bordering course behavior. So how we can model some course behavior patterns, some diagrams in notebook to depict some behavior of cost. So we know from the very beginning of this class that we can classify costs according to their behavior. That is how they change or how the costs react to changes in um, some of the variables that affect the cost. So with cost behavior, or if you want to classify cost according to behavior, we've said that we can classify costs into the cost being variable, being fixed, semi-variable or semi-fixed, also known as mixed costs. Then we can also have cost that behaves in a stepped fashion. That is the stepped phase cost. So all of these are there, and we can just create or write codes that can give us some nice depiction of these cost behaviors. So we start with that. Then we look at how we can segregate cost into its various components. So if you have a cost that is made up of two components, a fixed cost and some variable portions, how we can segregate it. So the various methods we can use to do that. And we can find that on, I think from pages 94 of our textbook. So when we go to page 94 of our test, we have segregating mixed costs into their variable and fixed components. So the very first method we see there is high-low method, or the high and low method. which is more or less like it's not so much scientific as compared to the other method, that is the regression method. But it is a way we can show how the variable cost portion can be separated so that we know that, oh, this is our 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 total cost. From this total cost, a certain portion is fixed. And to get a fixed, we can do this, do this, do this, then we get a fixed portion. The variable portion is this one. So we have some process, some simple steps we can use to elaborate the high-low method to separate our fixed cost from our variable cost. So if we have a mixed cost, we can use the high-low method to separate it into its various components. Okay, so we would also touch on that. Then if we have time, we touch on the regression method briefly. I think for the regression method, since we've all done quantitative methods, we have some fair idea about it, but would implement how we can use Python to also write code, Python code that will give us a regression output. Okay, so with the cost behavior that we were talking about, for you to depict a particular cost, you should sorry about that. So for you to model any particular type of cost, you should know and understand the nature of that cost itself. So if you want to create a Python script that gives you a diagram that shows how fixed cost behaves, you should first understand how the fixed cost data should be like. Then you create right from the get-go, you should understand that cost that you want to actually depict using a diagram. So if you want to create a variable cost diagram, you should understand what goes into variable cost and how a variable cost picture should look like, how a variable cost diagram should look like. So that boils down to the very understanding of the meaning of variable cost. If you want to do fixed cost, you should first understand what fixed cost is and how a fixed cost pattern is like. At least you should have a fair idea so that in generating the data to depict that particular cost, you'll be guided by that understanding. Then you create the right data that will give you that very diagram you are searching for. So if you know that fixed cost doesn't change no matter the level of activity, if you have that understanding right from the onset, it will guide you to use a data that is actually fixed over some number of activity levels. But if that understanding is not there, the code that you'll be writing, maybe you'll be using some costs that varies as output changes. And at the end of the day, the diagram you'll be producing or the output you'll be having as your cost behavior diagram will not be as you wanted it to be. So you should first understand the nature of the cost that you want to actually create. So let's do a simple a simple data to depict a fixed cost pattern. And to do that, because I have already imported my packages, I can just go ahead and I create my data. So I'm going to create a simple data frame that has quantity column, that has variable cost column, that has fixed cost column. Then we actually model the various columns, that is the variable cost column from the data frame we would create, the fixed cost column from the data frame we would create. So to do that, you can just do a simple code like I'm doing. So you just do quantity. So we are creating the quantity column. And for the quantity column, I want it to be a list with a range between, I can specify a range or I can just mention range. So it should just generate a list. And that list is made up of a NumPy range. So this range, as I've used there, is from the NumPy, the very first library we called. This range is from NumPy. So it is just giving me a range. Then we also do cost. So cost, we say that cost should be also a list. And this list should be a range having starting from 0 and ending at 100 in steps of 10. Then I call for quantity. Then I see if, then I also, okay, let me call for quantity first. So this is the quantity that we have. So you said that it should give me a range of 11 values. So since Python starts from 0, 0 will be the very first one. I have 0, 1, 2, 3, up to 10. Then let's print out our cost. So we print costs, then we run. Then it would also give us, we said that with the cost, it should start from 0 and end at 100, but in steps of 10, right? So this is our very first one. So 0, between 0 and 100, but in steps of 10. So we move from 0 to 10 to 20, 30, and the very last one would be 90, because after 90, the very next step will be 100, and that 100 doesn't fall between the 0 and 100 we specified here. Okay, so because we have this quantity specified and our cost specified, we can create a simple data frame. So in creating a data frame, we've already imported pandas. So we create our data frame to be maybe cost df. So cost df is assigned to cost df is assigned to pd.data frame bracket open, and our data frame, we specify that it should be the dictionary with the column quantity, and this quantity column should be equal to the quantity variable we've created here. So this quantity, this is the name that we are giving it, quantity, and it should be equal to this quantity we have here. So quantity should be assigned to quantity as we have there. Then we have the next one being cost. So maybe cost as we have it here. this cost should be put in single quotations because that is the name of the column. So costs being given the value. So dictionaries are created with keys and value pairs, keys and value pairs. So the key is the one in quotation, the red one, that is the key. And the value is the container or the variable we've actually created, which is this one, this cost. Then we call for our cost df. Oh, okay. I think I had to. So I'm coming. I think I'm having a little. Let me bring this down. So quantity is this. Yeah. Okay. So yeah. So it was because I had placed another curly bracket. Okay. So let's see if we are getting an error message telling us that let's read this line. So this line is saying all arrays must be of the same length. So let's see. So the very first one, the cost that we created is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then that is the quantity. Then the cost is 2, 4, 6, 8, 10. Okay, so let me just make this 110. Then I run it. So I have 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 11. Okay, let me make this 10 so that the two of them tallies. So we have the two being of the same length. Two. Yes, so it was because we were having the quantity, the length of the quantity. This became 11, while this was 10. That is why we're having the error message. So I've resolved that. So to create the quantity, use the range, you make it 10. Then you make this because this will start from 0 to be 0, then capped at 100 in steps of 10. right? Then you have from 0 to 9 being your quantity. Then your cost will be from 0 to 100. Okay, so this is a simple data frame. That is this cost DF. It's a simple data frame. So if you want to get any diagram out of this data frame, you can just call for that column you want to plot, right? So let's start from the quantity column. So to get the quantity column, you just call for the name of the data frame, that is the cost DF. So cost DF, then you specify that you want quantity column. Then you do dot plot. Then you specify that the kind should be a line. So that is you want to show a line, a simple line chart. So you start with the name of the data frame, then you specify the column. If you want to chart the entire data frame together too, you just do cosdf dot plot. Then you specify whether you want it to be dots or a line or any other form that you want it to be. We could have as well used Seaborn to actually do it. That one we can use it for scatter plot and all that. So let's run this and see. Yes, so our chart is ready. So this is our simple quantity chart. You could have specified the axis that, oh, show axis, this axis to be y axis to be this, x axis to be this, show the key. Madam Belinda, you are writing on my screen. So kindly try and take it off. Belinda. So that is it. So we've done this for the quantity. We can do same for the cost. So we call the name of the data frame itself. So the data frame, then we specify the column. So we want the column cost. Then we do dot plot. Then we specify that the kind should be a line plot. Then we just run. So because quantity varies this way, right? Because the quantity varied this way, and the cost also varied with the quantity. The two of them are just the same. It is just the calibrations that that varies. This side is from 0 to 468. Whilst here we have 0, 20, 40, 60, and 80. Right? So this is just how we can simply do simple charts. So you should first be guided by the nature of the cost itself, because you are creating it. If the cost data has been generated for you, if you've been given maybe a question, a quiz question or anything like that, and you have the values given, the columns specified with their values, that is much easier. But if you are creating the chart to depict that particular cost, you should be guided by the very understanding of how that cost should be. Then you create the data to depict that cost. So if you want to do something like a step phase cost, you should make sure that your data is in the form of a step nature. So if let me do something simple. So let me do stepped. So the stepped cost is assigned to let me just do the list. So the list, I'll do 120, 120, 400, 400, 450, 590, then 1000. This is our step cost. So let me just call for it, and it will, if I even call for it, it will just be printed out. So I have this step cost to be this. I can just do step cost dot plot. Then I show that I want the kind to be a line. Okay, so list doesn't even have the plot attribute. So let me just create a simple data frame for step cost and their quantity. So this is 2, 4, 6. So let me just make it 10. So I have 1,000. Let me make this 590, 590, 1,000, another 1,000. Then I already have the quantity there, right? So let me run this. Then I create a new data frame, right? I create a new data frame. So I do step df is assigned to pd.dataframe. Then this data frame is made up of a dictionary. That dictionary has quantity, and this quantity is equal to, or the key quantity has the value quantity, as we have already. This already quantity we have up here. This quantity we have up here. So this column. So from 0, 1, 2, 3 to 9. So it is 10 values. Okay. Then 10 values. Then we also have the cost. So the cost, let me name it first cost. This first cost as the key is having the value this step cost that I have created up here. So from 120, so it is also 10 in length. So 2, 4, 6, 8, 10. So the name is step cost. Then I call for step df. So let's see. So our data frame has been created. We have the data frame, the column being quantity, and the fixed, the step fixed cost side being this fixed cost, as we showed here. So let me just plot this fixed cost, because the plotting feature, or the plotting method is a feature of pandas data frames. So I can just do step df, then I specify the column I want to plot. So that column is called fixed cost. Then I do dot plot. I show that I want the kind to be a line. This line should be in quotations. Then I plot. So let's see. So this is our step fixed cost. Our step fixed cost is shown here. We are saying it is step fixed cost because we are saying the cost. Let's even look at it from the data frame side. From quantity 0, the cost is 120. When it moves to 1, it is 120. But when we move to quantity 2, it changes from 120 to 400. So this is it. So it is fixed over this number of quantities. When we move to quantity 2, it changes from being fixed to another level, from being fixed at 120 to another level of fixed cost of 400. Then it also maintains the 400 for some quantities before it changes to another level. It changes to another level. It remains fixed for some quantities, then it changes to another level and it maintains being fixed. So that is the nature of step phase cost. So before I can
Step,
even do this,
Go back.
oh, okay. So I'm going over it again. So I'm saying before you can even do something like step phase cost, you should understand how the data is, the nature of the data itself. If you are fortunate and the question you have has the data already in that form, you are good to go. But if you are the one creating the step phase cost, you should understand how the data should be. So what the data I used is a very even not so good. So let me make this one also 120. Make this 120 as well. Then I make these 700. I make this
So you've
700.
written 1,200.
Okay, thank you. Yeah, so 120, 120, 120, 700, 700, 700 here too. Then we move this to 1,000. So we still have 10, right? 2, 4, 6, 8, 10. Yeah, so let's run this. I run it, it's successful. Then I come and I rerun my data frame. Then it is now showing the new data frame, right? So from 120, it remains fixed over these quantities. From quantity 0 to quantity 3, it is still 120. But when we move from quantity 3 to quantity 4, our phase cost changes from 120 to 700. So this doesn't mean the cost is variable, although it is changing in response to quantity change. The fact that the cost has changed from 120 to 700 doesn't make it variable. It is still phase cost, but it is now moving from a lower phase cost to a higher phase cost. So from 0 to 3, it is fixed. But from moving from quantity 3 to quantity 4, we move from the old level of phase cost to a new level of phase cost of 700. So our phase cost will now be 700. Then it remains 700 for quantity 4, quantity 5, quantity 6. Then immediately we get to quantity 7, move to a higher phase cost again of 1,000. So let's see how that is also depicted. So yes, this is better. So as we can see, from quantity 0 up to quantity 3, it is fixed. It doesn't change. Our cost lies on this line, right? The 120 line. But immediately we move from quantity 3 to 4, we move from 120 phase cost to a higher level of phase cost of 700. Then it also remains fixed for some time, then it moves to a higher level of phase cost. So that is what I was saying, that you should understand how the cost itself is created before you can even attempt writing a code to show it. Okay. Any questions? If you have a question, you kindly unmute, then you ask. Or do you want to Okay, so I will take it as though none of us have any question. So let's move on quickly to the cost segregation. But before the cost segregation, I would like to shed a little light on indexing and slicing, because we would need it in our high-low method modeling. So if you want to model high-low, because we'll be making use of some portions of the data frame that we've been given, right? Because we'll be making use of some portions of the data frame, we need to slice, right? So we slice the data frame, then we tell the application to give us a certain portion of the data that we are using. That portion may be maybe the highest quantity and its associated cost, the lowest quantity and its associated cost, right? So the data frame will be there, but we need to slice that portion and we use it. So let me touch on that quickly. So for that, I would be making use of this example I have here. So I have here series indexing and slicing. We will still be operating with pandas data frames, and we'll still be operating with pandas data frames. But let me check if I've imported. So let me run this. Let me run this quickly. Yes, so it has been run. Okay. So I've run pandas already. So you can continue with this. So with this, I have a simple data showing countries, right? Showing countries, and the countries I have Ghana, Nigeria, Togo, Benin, and Niger. These countries, originally, when we create this list, right? Let me take this off for the meantime. When we create this list, it has been run. So let me maybe call for countries. When I call for countries, it will show me Ghana, Nigeria in the order that I specified, right? So if I want to show, maybe if I want to call for Togo, how can I call for Togo? Who can help us? If I want to call for Togo or print on Togo, how can we do that? Who wants to share an idea? How we can do it? Anyone? How we can print Togo?
Yeah, hello.
Yeah.
Yeah, please. So the Togo.
Kindly mention your name then.
Okay, I'm Nelson.
Okay. Nelson,
So the
go
Togo,
ahead.
if we use the index, Ghana is 0, Nigeria is 1, so Togo will be 3. So you enter the country and you write index 3. So
Togo
will
is
come.
3.
Yeah. Togo is
Okay.
2. 0, 1, and 2. Togo will be
2.
number 2.
Okay. That is fine. So if you
Hello,
want
sir.
to, yes. I'm listening. Kindly speak. Hello. Hello. Okay, let me go ahead. So if we want to show Togo, it means we would have to bear in mind that the original indexing or the natural indexing for all items we have here starts from, when we counting from left to right, it starts from 0, 0, 1, 2, 3, 4. So if you want to print Togo, we show, so just like this. So we can show countries, then we do 2. Yeah. So when we do this, it will give us Togo, right? But we can also create a series. Then after creating the series, or even if it's a data frame, we can use what we call iloc method, right? So the original one is the lock, right? So we can use iLog. The iLog one is the one that captures the items from the natural one. So the iLog makes use of 0 being the natural first item we have. So from left to right, when we call for 0, 0 will be the very first thing we have there. But when we use log, so we can use log and iLog. When we use log, log means you have specified the particular position or the particular index of that particular item. So let's create a series. Then after, we'll use that too. So in creating a series, you just do countries series. So let me take this out. So countries underscore series equals pd.series. Obviously, we've been doing pd.dataframe, pd.dataframe. We're just using series to do it. We could have used data frame anyway. So we just do pd.series, bracket open, countries, right? That is the variable. Then we specify that the name of the column. Selinum, you are writing on my screen. The name of the column should be countries, and it should be indexed. Have you seen this? This is what I was talking about. So with this, when we add this, when we pass this as part of the code, we are changing the original iLog indexing to log. So we are specifying the index that we want to give our data frame or the series in this case. So when we run this code and I call for countries underscore series, it will give me this. But originally, if I don't add this, it will start from 0. It will tell me Ghana is 0, Nigeria is 1, Togo is 2. But I have specified the index of all the items I have in the column. So because I have done this, if I want to call for countries, let's say the very first one we did, right? When we did countries and we called for 2, Togo came because Togo this is 0, 1, 2. So when we call for 2, Togo will come. But when we do countries underscore series, you should bear in mind that the countries underscore series has been indexed separately or differently. So when we call for countries underscore series, 1 will not be 0, 1. 1 will be Ghana because we've indexed the data that we have in the series separately. So let's see. So countries underscore series square bracket 1. It means we want the very first one we have specified in our series that we've created. So the series we created, we index them from 1 to 6. All right. So it was given 1, it gave Ghana 1, Nigeria 2. But originally, this data, the country's data, when we call for 1, right? Let me take the series off and let's call for 1. When we call for 1, 1 is Nigeria because the original indexing of this country starts from 0. So this will be 0, 1, 2, 3, 4. But because we've indexed countries underscore series separately, when we call for 1, so when we add underscore series to this, and we call for 1, it will tell us 1 is Ghana because we've changed the indexing of these countries differently in countries underscore series. And we've indexed it separately from 1 to 5. That is why when we call for 1, Ghana comes because we've said that it should start from 1. So the first item we have in the data set should be 1. When we call for 5, like we have here, 5 is what? Niger. But when we call for 5, in the original data, it will tell us that list index out of range, because the original one we have here, it will start from 0. So this will be 0, this will be 1, this will be 2, this will be 3, this will be 4. So we don't have 5. That is why we are getting an error message. Okay, so that is how iloc and loc works. So let's go back to our sheets. Then we look at high-low method. Change this to markdown and reduce the size a little bit. Yes. So let me number. So this is 1. This is 2. Yes. So we have cost segregation methods. We have high-low method, then regression. So we'll be starting with the high-low. So the high-low, it is less. I said earlier that it is less scientific because it makes use of just arbitrary identification of the values. So you'd have your data set there. And then we're saying that just pick the extremes. So we are just using the extremes to depict the pattern of that particular cost, right? So the extremes, we pick the highest activity level and its associated cost. This portion is very, very important. We always use highest activity level and its associated lowest activity level and its associated costs. We don't make use of the highest activity level and the highest cost, the lowest activity level and the lowest cost. No. When you check the data, let me go back. Yes, so something like this. The lowest activity level here, you can say is 0. So we pick 0 and we pick the associated cost of 0. Then we put them down. Then we go to the highest activity level, which is 9. Then we pick 8 associated costs. That is 1,000. We are not using lowest activity level and lowest cost. Maybe if the lowest cost is here, then highest activity level and this highest face cost. No. So let's get a good data, then we use that to experiment this. So it will be good we take note of this. Everything we are doing is still from the very course text that we have. If you don't have a copy, you kindly try and you get one. So we have a course data on page 97 of our textbook. So we are trying our hands on example 4.1. So we are trying our hands on example 4.1 and we are using the high-low method to do this. So we have a table there and that table has months. It has months, it has production units, and it has total cost. So we just do a simple pandas data frame. So let's start. So we just do costs. So costs data. is assigned to pd.dataframe bracket open. Then because you are coming to use dictionary, I open my dictionary, then I create some space. So the dictionary, I start with month. Then month as the key would have the values, I can use a list for that. So I use the list, January, comma, February. No, let me make them short. So Jane. The next one is FEB. MAR. APR. Yeah. So May. JUN. JUL. AUG. OCT. NOV. Then December. So DEC. So we have this. So we specified our month. Then we go to the next item, which is unit. So unit is also a list, and the unit using 800. That is the data we have in the textbook. The next value is 1,100, 1,200. We have 950. We have 1,300. We have 1,250. We have 1,000. We have 1,000 again. We have 900. We have 1,050 again. 10,200. So we have 2, 4, 6, 8, 10, 12. Then we bring comma. Then we go to the next item, which is cost. So total cost, and total cost is also assigned to the list. 93,000, 114,000, 119,000, 103,000, 126,000, 124. We have 107. We have 110. We have 105. We have 100,000. 110,000. Then the last one, 119,500. So we have our data frame ready. Then we call for it. Cost data.
Sir, please, we can't see. So if
It is the data is from the textbook, page 97. So kindly check.
sir, please, I'm not with the textbook at the moment.
Is it clear now? Because I just scrolled down. So
Yes, please, it's clear now.
yeah, so kindly run, or if you want to just observe what I'm doing. You can experiment it later at your own pace. So just look at how I'm doing it step by step. So I just passed this code, then I specified the months, started using just the short forms of it. The units, I just copied it as according to the question. Total cost, I just use list for them, right? Yes, you could have created months separately as a variable, units separately, total cost separately. Then we could have just referenced them and use them here. When you put them here together too, it is still acceptable. So we run this, then our data frame is created successfully. So we have from month 0, right? From month 0 being January. So this means this means this has been what? I-logged, right? Because it is using the automatic or the natural indexing of the data frame. So it starts from 0, ends at 11. It has not been logged. If you specify that the indexing of this data frame should be from 1 to 12, then you will see 1 to 12 here. Then this means you've used lock. Okay, so that is it about what I spoke about previously. So to use the high-low method, we are saying that you should just, we have 2 ways of doing it. It's even more than 2, but the book sheds light on 2 ways of doing it. So you should just use either the function. So you use the function way, then you create the algorithm for it. So the algorithm is just the step-by-step process that you want the application to go through to create something, or to provide a solution to something you want to do. Okay, so we can just do def. So this means we are defining something. So we just do def, then we specify maybe high-low. Then high-low should be taken from, so which data are we going to use for our high-low, right? The high-low we are coming to do, which data? So we are doing def, that is, we are specifying the definitions for the function, the arguments for the function, or the details of the algorithm. So def high-low and the data that we are going to use. So this data is what we are using. And this data is what we call cost data, or what we have called cost data. So you just specify cost data. Then you bring colon. If you don't bring the colon, it will not accept it because you are using def. Right? You bring your colon, then you specify. I've already said here that high-low, you need the highest activity level. So the highest activity level, let's maybe call our highest activity level X2. Then its associated cost, we call it Y2. Then the lowest activity level, we call it X1. Then we call its associated cost Y1. This is what we are going to use for our high-low. We are going to make use of the highest activity level and its associated cost against lowest activity level and its associated cost. So we can even curse, really. We can just curse our eyes on this data because the data is just 12. At times, the data that you'll be working with will be very, very huge, about 1 million rows, about 10,000 rows. And you cannot use your simple eyes to scan through the data and you identify the highest activity level and the lowest activity level. You will get it wrong because the data is very, very large, right? So you should just use tools like these to help you get it spot on. So, but from this data, because it is just 12, we can just check. Then we see that, oh, 800 is the least. So 800 is the lowest activity level. Its associated cost is 93,000. So that is what we'll be using. So this means that 800 will be X1 and 93,000 will be Y1. We didn't pick 800 as the lowest activity level, and we came here and we chose the lowest costs being, and maybe coincidentally, the lowest cost here as well is 93,000, which is coincidentally the associated cost for this 800 units. But you wouldn't always get it this way. So the principle is that it is the least activity level and its associated cost, not the least activity level and the least cost. If you pick the least activity level and the least cost, you will get it wrong. It is the least activity level and its associated cost. Then when we come to the highest is also 1,300. So it is the highest activity level and its associated cost, not the highest activity level and the highest cost. Here, the highest cost is, okay, this is even more. Okay, this is the highest cost anyway. So this is the highest cost, that is 126. And it is also coincidental that this 1,300 corresponds directly with the highest cost. This question is just for practice sake. That is why I'm emphasizing on the principles. So the principle is that it is the highest activity level and the highest associated costs, or its associated cost, not the highest associated cost, its associated cost. So it is the highest activity level and its associated cost, lowest activity level and its associated cost. Okay, so we can identify it this way. Then we use these key indicators to do the modeling, or we can give all the work to the application. So let's do the very first one. So we are giving all the work to the programming. So we are just saying that you should go and pick our highest activity level for us. So highest activity level, we've said that it is equal to what? X2. So highest activity level, X2, should be assigned to our cost data. So go to cost data, right? Go to cost data and search within the unit column. So this is it. This is the cost data. So we are telling you that to identify our highest activity level, go to the cost data frame. But when you go to the cost data frame, don't go to the month column. Don't go to total cost column. Go to the unit column and give us the maximum. The maximum, we want the maximum quantity or maximum activity level. So go to the unit column of our data frame and bring us the maximum quantity. And that maximum quantity is our X2. Okay. Then we go to the lowest. So the lowest is X1. So the lowest, we are saying that go to that same cost data frame. When you go there, enter the unit column, then give us the minimum. So mean. Give us the minimum. So the minimum is our X1. The maximum is our X2. Then we now go to our Y2. We said that Y2 is the cost associated with the X2. Right? So let's see how we can do that. So Y2, we are also saying Y2 is assigned to go to the cost data that we have, the cost data frame. When you go there, choose a particular column, right? That column should be specified this way. It should be specified as cost data units, then yes, cost data units, and that should be this cost data units should be equal to, because we've said that we are picking two figures here, the highest activity level and its associated cost. When we say its associated, it means it should be equal to, right? Not assigned. It should be equal to. So the cost that is at that highest activity level, so you'd have to make it 2 equal to signs. So we do it 2 equal to signs, then we show cost data. So what are we going in for? So we are going in for cost data, that is the maximum of the maximum cost portion that is associated with the maximum activity level that we specify. So we have that we should go to cost data, right? So cost data, we pick this quantity, then we are making it equal to, we want the cost that is associated with the highest activity level. So the highest activity level is cost data. We bring our square bracket here, we specify the unit, then we do maximum because we want the maximum. So the maximum quantity, then we show that this is where the slicing I spoke about comes in. It is at this point that we are going to use. Have you seen when we slice? Oh, I should have sliced this data frame. Let me cut this and let me cut this and speak about that one quickly. So if you want to slice this data frame, you can just do cost data, right? Then we show that, oh, maybe give us 2. So let's do this. And let's see if it is a method on it, it will work. Okay, it is not a method on the data frame. So it is not working. So let's just do, so it is at this point that you are going to use the iloc. So use iloc and you specify that give us, because this data frame is, it has index and axis, right? Every data frame we have here has index and axis. So we are using index 0, then we call for the second axis because the value that we want to show, right? The value we want to show is the cost. We are interested in the cost. So the cost means that this portion is the portion that we are saying should give us the value that is associated with this unit portion that we've identified. So this portion is just that we are doing lookup in Excel. So you'd have to specify the lookup range and the lookup value, right? So here too, we just want the cost that is associated with the highest of this. So when you check for the maximum of the units, right, this portion, right, give us the costs. So it is this portion that will specify the cost. Give us the cost. So it will give us the cost column associated with the highest of this. If you don't bring this portion, you will not get the cost part of it. This will work all right, but that means that Y2 is equal to something, but you've not really specified that particular thing to be specific. So to do it in more specific terms, you'd have to slice, right? You'd have to slice the data frame to get the exact portion that you want. So you specify the index as well as the axis. So you do it this way, then you would have your Y2 intact. Then we specify the Y1. So it will still follow something similar to this. So we do cost data. Then we do cost data units. And it should be equal to cost data. We bring square brackets, units. But this time around, we want the minimum. So we do minimum, and it should still give us the 0 indexed, but on the second axis. That is where we would locate the cost. Okay, because this is 0, this is 1, and this is 2. So if you do 0, 1, and you call for Y2, Y2 will give you the value that is here, the highest unit that is here. But because we are calling for 0 axis, 0 indexed, and the second axis, it will not show this. It will not give us this column. It will not give us this column. It will give us a value from this column. Because this is 2, right? Yeah. Because this is 0, this is 1, this is 2. Okay. Then I think we have these specified. So we can go to we can show if we really want to see the answers that we have here. We can do print, right? We can do print. So the print, you can use a function. So print the highest activity level is equal to, right? Then we end the quotation. So the highest activity level is equal to, or maybe is, then we specify that it should be equal to, the highest activity level is x2. This x2 is in curly brackets, just like we create the dictionaries. Then we do print the lowest activity level is, we put it in curly brackets, x1. Then we end our function. We do print the highest total cost. Is the highest total cost, we've said it is what, y2. And we end it, and we go to print the function, the lowest
So
total
please, can you
cost.
see anything?
You can't see. Let me try and zoom if that would be possible. I think this should be better. Can we see it now?
Sir, please, no, I still can't see.
I've actually zoomed it, but I don't know why it's not reflecting on your side. But let me see.
Sir, you see, the thing is that when
You should
I
zoom
keep
side.
my screen straight, I can't see anything unless I slant it. And if I slant it, so it's only giving me up to the def high, low something. That's the only part I can see.
I've actually zoomed my screen, but so you should be seeing the zoom screen now. Are you seeing that?
Okay, I'm now. Yeah. Hey, I did.
Okay, so let me continue. So just that it will be shifting, right? Yeah. So let's manage. So the lowest cost, you said it is x, or the lowest cost is y1. Then we end with a apostrophe. So all of these have been created. So to show costs, you can decide to add Ghana cedis or we ignore, but most appropriately, we add Ghana cedis to this to show that these are monies, right? Yeah, we can yeah, I think we can run this, then we see if
Please, I'm not eating since morning.
would close just about now, so you can go get something to eat. Yeah, so we have this here. So let's see if our code will run successfully. So our code has run. So it was 30. Now we have 31 here. So these are all right. Right. So to actually see what we've done, right? To see what we've done, you would have to call for the function that you have created. And the function we created is called high low into bracket cost data. let me see. Let me take this down. And let's see what. So let me see. No, let me run this again. Okay. Okay, so the issue is actually here. So let's see then. So it is telling us that we have an issue with the Y2, right? So Y2 cos data, the unit, this one, they are saying we have an issue with it. So let's check. So we have Y2 here. We have the cos data, and it is telling us, yes, so our cos data is the data frame we are using. And from the data frame, we are using this column, right? Cos data with a list or that particular column called units. So we are using units, and this unit should be equal to the cos data column, another one unit. But here we are calling for the maximum. Yeah, and I think it is right, but mm, um, we have our x1 being specified. We have our okay. Let me. Oh, okay. So I should have used lock. I should have used lock here. Then I should have used lock here as well. Okay.
He said, please, I'm not eating. No, my head is aching.
Who is the one speaking? Who are you? Just mention your name. So let me add the other portions of this. Let me specify because our let me try completing it and we see if it would actually work out because I have everything intact, but I don't know why I'm having an error message. So let's add the other portions. That is the variable cost per unit portions and the other portions. So variable, we can do just variable cost per unit. And we do variable cost per unit being assigned to, then that one, we just create a formula. So that formula is y2 minus y1 divided by x2 minus x1, right? Then we specify our fixed costs. So our total fixed costs being assigned to Y2, which is our total cost, minus our variable cost per unit times unit. Because variable cost per unit times unit will give us our total variable cost. So when we subtract this portion, the total variable cost from our total cost, we will get our total fixed cost. So this is how we get our total variable cost. Then we find our total cost as well. So total cost will be what the function would actually do, right? The algorithm, it will model the total cost for us. So we can leave that one out for now. So we can also print the total. Maybe we can show that we can do a function to show variable cost per unit. And variable cost per unit is, and then we show that variable cost per unit is what we've allocated a certain value, and that value is in the variable cost per unit. Right? Yeah, then we complete it this way. Yeah. Then we also show print from the information that we have total fixed cost. And total fixed cost is the total fixed cost variable we did. Then we can finally specify the printing of our cost volume equation. So the cost volume equation, we are saying that the equation for the cost volume is equal to, right? Then we can maybe move, we can decide to move this to the next line by just doing tab. I think the other time I spoke about it. So we do backslash, which is here. Yes, so backslash and n, right? That is go to the next line, right? Yeah. So to go to the next line, it will show this equation for total cost volume. Let me make this equation for total cost. Yes. So that is equal to, then we specify the output. So that output should be, or the equation should be equal to total variable, total fixed cost, plus the variable cost per unit that we have. So var cost per unit times the production unit. So our production unit is units. But this unit, because it is something like, if we are writing it else, we would have written maybe A plus BX. So this portion is the fixed cost portion, which is the A, plus B. So B is the variable cost per unit portion of the equation. So it is A plus BX. So X is the unit. So to get the total cost volume equation, it will be total cost being equal to this portion, that is the fixed cost, the autonomous variable, the A, plus B. B is the variable cost per unit, and we specify that here already. So variable cost per unit is the change in total cost as a result of change in quantity. So Y2 minus Y1 divided by X2 minus X1, right? And that will give us our variable cost per unit. So we can decide to even include slash. Yeah. Then we close it with a closing parenthesis. Yeah. So this will be our function. So it has run successfully. It was 38. It is now 39. Let me run it again. So this is 38. It has run successfully. So this has been taken, right? So anytime we call for high-low cost data as we have it, right? High-low using information from the cost data frame that we've created. When we call for it, it will give us all these things, all the instructions we've given it. We tell it that print for me to see this. It will print it out. Print this for me to see. It will also print. All the print will show. This will just insert a line. This print, it will just insert a line. It will just you printing an empty line. This one. So this print would come. This print, all these 4 prints will show. This print would also insert a line. Then these 3 would follow. So you would have the highest activity level showing. You'd have the lowest activity level showing being referenced from X1, and X1 has been identified here. X2 has been identified here. Y2 has been done here. Y1 has been done. So when you call for high-low cost data, everything you've done here would show. So high-low into brackets cost data. Then you run. Any questions so far? Any questions? If you have any question, just unmute, then you speak.
Hello, sir.
Yeah.
Sir, please.
Kindly mention your name then.
Please, my name is Gabriel Apom.
Gabriel, okay.
I wanted to know if the first code you ran.
I don't think that is that where your interest is. I think your question should be related to maybe something. You shouldn't be interested in whether an error has been corrected or otherwise.
Yes, please. I wanted to know if we at the end of this we get the answer for the high low. That is why I asked that question.
Okay. So
Thank you, sir.
this is actually how it is supposed to be. I've used different variable names. I've changed it a bit, slightly from what we have in a textbook. But if you follow what we've just done, right from identifying, right from understanding how you can even get the maximum figures, the maximum units, the maximum maybe its associated cost, the minimum unit, its associated cost, and all that. You'll be fine. So okay, I've actually seen a problem. So I should have used square brackets for the locking and not parentheses. So let me just do that, then run. Let me run this again. So I have this. So let me call for high-low cost data, and our answers are here. So Gabriel, if this is what you want to see, this is our answers. So the highest activity level is here, 1,300. The lowest activity level is 800. Highest total cost is, so just like we specified here, everything has been given, just like the instructions we gave it. And that this is an algorithm. Algorithm sounds so big, like a big word, but there's nothing strange. Every instruction we've given here, just by the calling of this, it just gives us everything in that systematic order. Yeah. So the total, the highest activity level has been shown, 1,003. Lowest activity level has been shown, 800. Highest total cost has been shown, 126,000. Lowest total cost has been shown, 93,000. And it has given us the variable cost per unit to be 66. That is when you find the change in total cost as a result of change in quantity. So you do y2 minus y1 divided by x2 minus x1. And you have this 66. Then the total fixed costs, that is when you find the variable cost per unit, that is this 66, and you multiply by the highest activity level, that is 1,300, you get this 40,200. So that value minus the highest cost will give you the 40,200. That is the fixed cost, because the total variable, the total cost minus the total variable cost, that will give you the fixed cost. Then we printed an empty line here. That is why this line is here. Then the variable cost per unit follows, this one. Then the total fixed cost also follows. Then the equation. So this one is the equation for total cost is. And we said it should move the rest to the next line with this. That is why the is paused and the other details appeared here. So it is equal to total fixed cost plus variable cost per unit. That is why we have this here. So 40,200 plus 66 per unit. Yeah, so let me make this even 1s. That's per unit. So it should be 1, yes. So that is our answer. So this is one way of actually doing the high-low method. There's another method that can be found on page 101. Yeah, we would look at that at our next meeting. Please, any questions?
Yes, sir, please. I want to know, in printing the highest activity level, you always bring F before the parentheses. I want to know the meaning of that F.
Yeah, it is F because you are creating a function. Have you seen? We could have just done print, right? You could have just done print the total highest activity level is, and we just show x2. But everything we are doing here, because we are modeling and it is a function that we are actually creating. That is why you should have this F. It means it is just a function. So print the function x2, but let it be preceded by these words. That is why. Are you okay? Okay, so I'll take that as a yes. So we'll end here for now, and we'll continue next week if we don't have any other questions. So in summary, today we've looked at something small on cost behavior patterns, how we can create cost behavior patterns. We've looked at how we can change the indexing of some series or a data frame from the natural indexing to a user-defined index. That is changing from iLog to log. The original one is iLog, the natural one, the one that starts from 0 is iLog. Then you change it to your user-defined one, that is the log, right? That is what we actually made use of. So we used log here. We could have cleared this. You can clear this one, it will still work. You can clear this log to the log here, you can clear it, it will still work. But this iLog is very, very important because you would have to specify the index that you are you are searching for. And here we want the maximum cost. And the cost can be found on only the second index. So this is 0, this is 1, this is 2, right? So 0 axis, 0 index, and 2 axis. So with that one, it will pick 0, 2. And 0, 2 means you shouldn't move, because if you take this off, right? Let me just do this one. Let me copy. I think time is up, so maybe this might take some time. So let me hold on for now. But we've looked at the log and the high log. Then we've also looked at how we can model the high-low method, specifying the full cost equation using the functional approach. So using an algorithm, we defining how we want to create our function, and that our function has only 4 variables. So x2, x1, y2, y1. Yeah. So we'll end here, then we'll continue some other time. So bye-bye for now. Lydia, is your hand up? Lydia Jemfi, I don't know if you want to speak. Okay, so I will take that as a mistake. So bye-bye.